Hey everyone, welcome back to the third lecture of our placement series. So in this video, we'll be talking about merge sort, which is one of the most important sorting algorithm and which is mostly asked in the interview. If you go to any of the company's interview, you'll be expecting a question from merge sort definitely, because this is such an important algorithm. This is not that super easy to understand and this is not that super difficult also to understand. When I talk to students, they often call me that I can understand merge sort while I watch some videos or while I read somewhere about merge sort, but after maybe 1 month or 2 months later, I completely forget how merge sort actually works. Then I just say one thing, that you by hearted all the steps of the merge sort you couldn't understand. So in this video, I'll try to explain merge sort in such a way that you will never forget what is a merge sort, how it works, and how to actually write code for merge sort. So let's jump to the video, but before that, if you are new to this channel, please subscribe to my channel, because this is the only thing that inspires me more and more to make such kind of videos. And also, if you like this video, please hit the like button. So the simple concept of merge sort is inside the word merge, right? It is merge and sort. So what does this merge means, right? This merge means if we have two different objects, we can concatenate that object and we can make a single object. So that is what merging means, right? So in our case, let's say we have two arrays. We want to merge two arrays into one array. We have two linked lists. We want to merge two linked lists into one complete linked list. So this is a kind of thing that merge actually means in the form of data structure and algorithm. So let's see how this simple merge can actually do a magic in case of sorting algorithm. And let's see the beauty of merge sort and why it is one of my favorite algorithm. So first, understand how people have actually come up with this merge sort concept. If you cannot understand why you are actually applying some steps or why you are applying some algorithm, you cannot understand and you cannot remember for a long time how merge sort actually works. So first, understand the basic thing. So you might have heard that merge sort have 3-4 number of different steps. You can keep on dividing array and you then merge something. But why do we actually do these steps? Let's find out the beauty of a sorting algorithm. So let's say we have two different already sorted arrays. So that means this is array 1 and this is array 2. All these arrays are already sorted, right? 8, 15, 27, 35 is already sorted. 2, 5, 18, 62 is already sorted, right? So these two arrays are itself already sorted. Now, how can we make another big array which consists all the elements inside these two arrays, which consists all the elements, like all the 8 elements, like 4 elements in array 1 and 4 elements from array 2. We combine all the 8 elements and we can merge and we can combine a single array so that the bigger array would be sorted. Let's find out how we can do that, and you can easily understand why we do these kind of things. So first, let's say we have two arrays, two already sorted arrays. We want to combine, we want to create a bigger array of having the same elements from these two arrays, but we want that bigger array to be sorted. How can we do that? So let's say we are setting two pointers. Let's say this is I pointer and this is j pointers to the beginning of both the arrays, right? And we are creating our bigger array. Now what we do, we just shift our pointers from left hand side to the right hand side of both the arrays. Now we compare the ith value as well as the jth value. Which is smaller? We keep on putting the value on the bigger array. So from 8 and 2, which is smaller? 2 is smaller than 8. So we put 2 here and we increment the value of j. So j should be pointing there because 2 is already taken, right? Now we compare 8 with 5, which is smaller? 5 is smaller, and I increment the j pointer to this place, right? Now 8 is smaller or 18 is smaller? 8 is smaller. So I write 8 here. I just increase our I pointer. Now tell me 15 or 18, which is smaller? 15 is smaller. So I write 15 here and I increment that pointer to this place. Now you say 27 versus 18. 18 is smaller, write 18 here and just shift the j pointer. Which is smaller? 27, 62. 27 is smaller. So I just keep on incrementing the I pointer. Now 35 versus 62, which is smaller? 35. Now we just incrementing our I pointer, but it is out of the array index. So I found that this array, this first array, has no other elements left. So what we have actually, we have a single element left on the second array and we just copying that second element, right? So this is our already sorted arrays. So just see how quickly we can get the result. We can get the desired sorted array from two of the already sorted arrays. So if I ask you what is the time complexity, if you don't know how to calculate time complexity, please watch my previous video, the first lecture I cover time and space complexity. Please go and watch that and then tell me what would be the time complexity. Just pause the video and tell me in the comment section what would be the time complexity of creating a sorted array from already two sorted arrays. So let's say the first array has n number of elements, and let's say the second array has m number of elements, right? So first array has n number of elements, second array has m number of elements. Now what we are doing, we are basically running a pointer from the left hand index to the right hand side, and from the left hand side of the second array to the right hand side of the second array. So in every case, this is not the worst case or this is not the average case or best case. In every case, what we have to do, we have to run a pointer. We have to run this I pointer from the first index up to last index, right, in the first array, and we have to run this j pointer from the first index up to this last index in the second array. So what are the total number of comparisons we are doing? We are doing basically n plus m number of comparison. If I can simplify it, let's say both the arrays have already n elements, so we are basically taking 2n number of comparison, right? What will be the asymptotic complexity? Order of n only. So this is the beauty of merge sort, and this is why this merge sort actually came into picture, and this is why we use such a steps in the merge procedure. So this is the base case. Now we can focus into how merge sort actually works and why we are following 3-4 different steps. You might be heard of merge sort will take 3-4 different steps. Why we are doing, let's find out. Now let's say you have an array 8, 15, 27, 35, right? This is the first array. As we already saw, this was the first array. Now if I can say that this array is already sorted, right? 8, 15, 27, 35, this array itself is already sorted. Now if I say that you got already sorted bigger array from two of the equal sized smaller arrays. Now if I can say, if I can apply the same logic here, that this array is already sorted. Now can I say that this array was formed using two of the smaller arrays which were already sorted? Can I say that? Of course, yes. So in this case, this is our new bigger sorted arrays. So what was our smaller array? It could be anything, but those two smaller arrays itself should be sorted. So right. So we can have an array combination like, let's say the first array takes 15 and 27. The second array might be 8 and 35. So this could be our two smaller arrays, right? It could be anything. It could be 15 or 35, or it could be 27 or 8, whatever. But let's consider this was our previous array. This was our smaller array, and with that smaller array we combine and we merge together to form a new array. So we can see that this already sorted arrays was found using the two smaller arrays which were already sorted, right? Using the same logic, can I say that, hey, this array is already sorted, this array is already sorted? Can I say that these two arrays are a combination of two sorted arrays? Can I say that? Of course, yes, because we have already seen how we can combine two of the smaller arrays, two of the sorted smaller arrays to form a bigger sorted arrays. We have already seen. So can I apply the same rule here? Obviously, yes. So I can say that this could be an array 27 or 15. These smaller arrays, this could be an array 35 and 8. These two smaller arrays combine together to form these big arrays. These two small arrays can combine together to form these two arrays. Can I say that? Of course, yes. A single element array is already sorted. So now that is the beauty. That is the beauty of merge sort. Can you figure out what something is interesting happening here? You can see that if we have all the single elements, let's say it could be anything. It could be 27, 15, 35, 8, or it could be 27, 35, 15, 8, or it could be 27 or maybe 35, 8, 15, 27, whatever the combination it would be. But with any of the combination, I can form these two of the smaller sorted arrays, right? With these two smaller sorted arrays, I can form this array, And with this array, along with some other sorted arrays like this array 2, we can have a bigger array which will be already sorted. Can I get that? Yes. So this is the basic principle of merge sort. So you have found a very important rule here, that if we somehow can break the entire array into several parts of single element, right, we can get our entire sorted array in the same way that this merging is actually taking place. So let's see how merge sort actually works and what are the different algorithms. You can remember that, but if you can understand, you don't need to remember anything. Everything will be stored on your brain. So let's say we have an array consisting of 8 elements, which is obviously not sorted, and we want to sort that array, right? We can find a middle element, right? So this is our middle position. We can find a middle index. It could be this, or it could be this, or it could be this. So we can find any of them, and we just divide that array. So our two of the new arrays would be 27, 8, 15, 35. This is our array, first array. Another array would be 5, 2, 62 and 18. So what we did, we just divide the bigger array into two of the smaller arrays of having equal size. It can be equal, it cannot be equal. Like if you have 9 elements, how can you divide it equally? So you have to divide an array having 4 elements, another array would be having 5 elements, right? So now what we can do the same thing again. We can divide this array as well as we can divide this array. So what would be this array? 27 and 8. And the second array would be 15 as well as 35, right? What would be this? 5 and 2, 62 and 18. So if you have understood this merge procedure, why we are actually breaking that array, you can understand why actually we are doing these kind of steps, right? So what option do we have? This array, this smaller array would be broken into two of the similar parts. It would be 27 and a single array, single element array, it would be 8. So we can break this array also. It would be having 15 and 35. Similarly, it would be having 5, it would be having 2, it would be having 62 and 18. Now all the elements of this array has been broken into several parts. So what can we do now? Can we do a magic here applying the same merging technique? Yes, of course. And that is the beauty of merge sort that I already explained in this step. So let's see what actually happens. So we have two smaller arrays, 27 and 8. What we can do? We can merge together, right? To form a new array having 2 elements which will be already sorted. How can you do that? Which is smaller? 8 is smaller. Put 8 in the first place. Which is bigger? 27. So this is our already sorted arrays having 2 elements. How can we do that? We can merge together again these 2 elements. What would be this? 15 and 35. Using the same technique. How are we merging? Using the same technique that we used here. Put a pointer in the first array, put a pointer in the second array, and traverse the first array entirely, traverse the second array entirely, right? So we are doing the same thing. What would be here? What would we be doing? It would be 2, it would be 5. What would be the result? It would be 18, it would be 62. Fine. Now what option do we have? How can we get another sorted arrays having 4 elements? So we can merge these two. What it would have? 8 versus 15, 8. Then we can shift the pointer here. 27 versus 15, 15. Then we can shift the pointer here. 27 versus 35, 27. What we have left? 35. So the entire array having 4 elements which is already sorted, we have got 8, 15, 27, 35, right? What we can do? We can merge these two arrays together in the same fashion. It would be 2, 5, 18, 62, right? Now how can we get the bigger array? We can merge these two arrays, as simple as that. So the similar fashion, like putting the I pointer here, putting the j pointer here. 8 versus 2, 2 is smaller, increment this j pointer. 8 versus 5, 5 is smaller, increment this j pointer. 8 versus 18, 8 is smaller, increment this I pointer. 15 versus 18, 15 is smaller, increment this I pointer. 27 18, 18 is smaller, increment this pointer. 27 62, 27 is smaller, increment this pointer. 35 62, 35 is smaller. What option do we have? 62 is left, so put 62, right? So this is our newly constructed array which is already sorted. 2 5 8 15 18 27 35 62, which is already sorted. Can you see the magic of merge sort and how we can get that merge sort? People will say that, hey, in the merge sort we keep on dividing array into a single elements, then we do the merge operation. Why are you doing that? Why actually you are doing this operation? You have to understand, and for that, if you have understood how this merging procedure works, you can understand this merge sort quite easily, and in just a few couple of minutes you can understand the entire merge sort algorithm. So now first tell me one very simple thing. What could be the time complexity of merge sort? Let's see very carefully and let's pay attention, because this is important, and this question will be asked in many of the interviews, that please derive the time complexity of merge sort. You might be saying, hey, we know the recurrence relation of merge sort and we can solve the recurrence relation, but interviewer will not select you because you don't know how to derive time complexity. Let's pay attention here. Let's say we have a bigger array, right? Now what we are doing, we are keep on dividing this array into two equal hubs. So we got two arrays of having 4 elements. Initially we had 8 elements. We also divided this array into two equal parts having 2 elements each. So how many number of arrays we had? 4 different arrays. What we did, we divided it further having a single element array, right? So how many steps we are taking? In each step, let's say n, if n would be the size of the array, let's do it in phrase. Let's say you have n, which is the size of the array. In every step, what you are doing, you are dividing the array in two equal hubs. So what would be the number of elements? It would be n by 2, right? So why am I doing this? Because you will be doing this process until a single element is present inside your array. Now further, if we divide, it would be having n by 2 square elements, like n by 4. Further division, it would be having n by 2 cube elements. So let's say we are doing it up to k times, like we are doing the division up to k times, and we are having n by 2 power k elements in each of the array. So when will we stop? If that n by 2 power k is equal to 1, right? So from that equation we can get 2 power k equal to 1, 2 power k equal to n. It would be k equal to log of n base 2. So how many steps we are actually doing? We are actually doing this entire step would be doing in log n different times, right? So this is often called as the recurrence tree. Why recurrence tree? I'm going to explain now, because when you see the actual algorithm, actual code, you will find that it would be a recursive function, and for all the recursive function, you will be having a recurrence tree. So we have log n different levels inside our recurrence tree. Now we have to find out in each of the level how many number of operations we are doing. Let's find out. So in this level, in this base level, where all the arrays having the single elements, how many operations we are doing? We are comparing this element and this element to combine this array. Again, we are comparing this element with this element to form this array. Again, we are comparing this element and this element to form this array. Again, we are comparing these two elements to form this array. How many comparison we are actually doing? If this level has n number of elements, we are actually doing n comparison in this level. Let's see how many number of comparison we'll be doing in the second level. If this is having 2 elements, this is having 2 elements, how many number of comparison? It would be 4. If this is having 2 elements, this array would be having 2 elements, how many number of comparison? 4 again. So total 4 plus 4 is 8. Again the same. So this would be again n, considering n would be the number of elements inside that array. Again we form these two bigger arrays, and we want to form a single big array having 8 elements, which will be already sorted. How many number of comparison we are doing? It is having 4 elements, it is having also 4 elements, total number of comparison is 8, which is also having n, right? So you have found out one very interesting thing, that in every level of your recursive tree, you are doing n number of comparison, right? How many levels are there in the recursive tree? Log n number of levels are there. So what will be the time complexity? N number of different comparison in each level. How many number of levels? Log n number of levels. So the time complexity will be simply order of n log n, which is a drastic improvement over order n square algorithm, which you might often see in insertion sort, selection sort, bubble sort, etc. Now let's look at how to write the code of a merge sort algorithm and the most important thing, how to write the code for the merging algorithm, because this is the most important thing. Writing merge sort algorithm requires only 3 to 4 lines of code, that's it. But writing the merging procedure is very, very important. Now let's look at the merge function. So what are the parameters? So there could be a single array, int array, right? Because we are actually dividing the same array. We are continuously dividing the same array and continuously dividing the part of the single array. So our array is fixed, right? But the index will be changed. So we require an array. We also require a left pointer, which is pointing to the left index of our particular subarray. We need also a right pointer. And most importantly, we need a middle pointer. If you can look carefully, every time we are dividing this single array into 2 hubs, and at the end we are merging 2 adjacent subarrays. We are not randomly merging one subarray from left hand side, one subarray from right hand side, extreme right hand corner. No, we are continuously merging 2 adjacent subarrays. So this subarray will be merged with each adjacent subarrays, and this subarray will be merged with each adjacent subarrays, right? So for adjacent subarrays, there should be a common element, there should be a common index, and that's why we need a middle element. First, we have to declare 3 different integer variables, let's say I, j, and k. Now we need to find out how many number of elements each subarray contains. So let's say the left subarray contains n1 number of elements and the right subarray contains n2 number of elements. So what should be the value of n1 and n2? Let's find out. Now let's look at a simple example. Let's say we have an array having 4 elements, 0, 1, 2, 3. And we are dividing the array in 2 parts. So what would be our middle index? If we can consider this to be our middle index, so how many number of elements that left subarray will contain and how many number of elements our right subarray will contain? The right subarray simply contains r minus m number of elements, because this is our r, right? And this is our m. So we need 3 minus 1 equal to 2 elements, 1, 1 and 2. 2 elements on the right subarray. How many number of elements would be in the left subarray? Just look carefully. It would be m minus l. So 1 minus 0 is 1, but we have 2 subarrays, so it would be plus 1 because array index starts from 0. If we want to count the number of elements, we have to add another 1, right? So this is clear, I think. So we have found number of elements in the left subarray and number of elements on the right subarray. Now we have to declare 2 temporary arrays that will hold the elements of the left subarray and right subarray. Why? Because later we found out that we actually need to modify our existing array. So we need 2 integer arrays to be created. So let's say int l, and how many number of elements the left subarray contains? We already got n1, so l of n1, and let's say a right subarray which will contain n2 number of elements, right? So we are declaring these 2 arrays. Now our task is to store the left subarray into L, the right subarray into R. So what we do, we just run a loop for I equal to 0, I less than n1, I plus plus. So we just copy the value from left subarray to our L array, right? So L of I would be array of L, which is the left pointer, plus I, right? So when I is 0, L of 0 would be array of L, L of 1 will be array of L plus 1, and so on. So this is our first for loop. We run also a second for loop to copy the same elements. Let's say j equal to 0, j less than n2, j plus plus. What we do r of j, it would be equal to, the index from the right subarray will start from m plus 1 element, right? As you can see, m is here is 1, the index of the right subarray would start from 2, so it would be m plus 1, right? So that's why it is m plus 1 plus j for the index. Now what we have to do, we have to merge these 2 subarrays. So we compare elements of this L array as well as this R array, and depending on that we modify our original array. So first of all, we run a loop that will both run from the left index to right index of both the arrays, the L array as well as the R array. But before that, let's initialize few of the variables as our initial condition. I equal to 0, j equal to 0, and k should be equal to pointing to a left pointer. What is k? Let's see in the next part of this video. First, we'll run a loop that will both run this L array as well as R array. So while I is less than n1 and j is less than n2. Now what we do, let's say I am again explaining with a simple example. Let's say these two are sub arrays. So we divided these two sub arrays. This is our L, this is our R. I is pointing to this position, j is pointing to this position, right? Now this is our main array, 1 2 3 4 5 6 7 8. This is our main array, and k is basically pointing to this position. This is our array, right? This is our original array, and this is the L array we have created. This is the R array we have created. So what we did, as I already explained here, we just compared the ith element as well as the jth element, which is smaller. We just took that element, put it into our final array, and we just go on to the next elements. So we have to do the same thing. This is our L array, this is our R array. We compare I and jth position. So if L of I is less than or equal to R of j, what should we do? We should take the smaller element and put it into our final array. So we take this array of k is pointing to this point, right? Array of k should be equal to L of I, because in this case L of I is less than or equal to R of j. So that's why L of I is smaller. We just put here. What would be the else? It would be R of j greater than L of I. So we'll write just else. What would be the steps? Array of k should be equal to R of j, right? And we also increment this j plus plus, because we have taken this j value, we have to increment here. And from these two statements, if and else statement, only one will be executed. Now we have filled out this position, right? So we have to increment our k pointer. That's why we write k plus plus. So this is our while loop. From here to here, it would just compare and merge, compare and merge, compare and merge, right? Only two things are left. Let's say these two are of unequal size. Let's say this has 5 elements and this array has 4 elements. So total number of elements would be 5 plus 4 equal to 9. Now one array is completely taken, right? Let's say this array is completely taken, and there are few elements from this array is already left, because we have no other option to compare, because already this array, all the elements of this array are already taken into this final array. We have no other elements to be compared. So we just copy the remaining elements to our existing array, to our final array. So we know that our I pointer will be incremented to a particular position where all the elements of the array will be full, right? So we write while I is less than n1, what should we do? Array of k would be L of I. We should increment I plus plus. Also we should increment k plus plus, right? Because we have to increment I from here to here, from here to here, and we also increment k from here to here. Similarly, if right sub array have some elements, so we just see j less than n2. We just took array of k equal to R of j, j plus plus, k plus plus, right? So this is our entire merging procedure. Again, I am explaining, we are passing the parameter, we are passing the main array as a parameter, we are passing the left pointer, the right pointer, and the middle index, which is the common index, right? We are declaring 3 variables. We also calculate how many number of elements should be present on the left subarray as well as the right subarray. We just created another array L and R, and these two arrays are a temporary arrays, just works as a temporary array, and we just stored all the elements of the existing left and right subarray to this array, and we just keep comparing with these L array elements with R array elements, and whatever the result would be, whatever the smaller element would be, it has to go to our main array. Now let's see how to write the merge sort algorithm, which is very easy. 3 to 4 steps you have to just write. This is very easy. So for merge sort, what we need, we have the current array, we know what is the left pointer, we know what is the right pointer, and we know what is our array. So we are passing these 3 parameters into a merge sort. We don't require middle element because we need to calculate the middle element inside this merge sort algorithm. So now let's say, and also look at this parameter, this is void because this is not actually returning anything, because it is actually modifying our current and existing array. Let's declare the middle element int mid it would be what would be mid? It would be L plus R minus L divided by 2. I always write this middle element formula in this way. You can write also L plus R by 2, but I don't recommend that because it would give you integer overflow, right? So I don't recommend to write this way. I always suggest you to do this way, L plus R minus L by 2. Now what you did in the merge sort, you keep on dividing this array, right? First you divide this array, you got two different subarrays from here to here, from here to here. What you did, you again divide that array, right? You again divide that array, you again divide that array. So you see there is a recursive pattern. So that's why you have to write some recursive function. It would be merge sort. So what would be our parameter? The same parameter array. What was our two other parameters? One is left pointer, one is right pointer. So what was our left pointer? It would be L always. And what was the right pointer for the new subarray? It would be M only. And what would be our second recursive call? For the right subarray, merge sort array mid plus 1 and R. Right? So now those two merging recursive calls are done. We have to call now the merge procedure. So let's write merge with the same array, with a same left pointer, with the same middle and with the right pointer. Now can you find out which of the thing is missing? Can you find out? Can you just pause the video and comment it down? Which of the things in this merge sort procedure is missing? There should be one thing missing. The answer would be the base condition, the base case. For every recursive function, we need to stop the recursive call at some point of time. So that's why we need a base case. So which would be our base case? Let's find out which would be our base case. So let's say this was our initial array. I just changed the color. So let's say this was our initial array. From this position, we got these two subarrays. We further divided these two subarrays from this, and from the right subarrays, we got another subarrays from this and this. We kept on dividing until we get a single element. So what would be the condition? When your left as well as right pointer is merged, right? For a single element, your left pointer and right pointer will merge to a single position. So we have to just write here a single condition. If L is less than R, we will be doing this sort of operation. If L is greater than R, or at least if L is equal to R, we'll stop our merge procedure. So this is our overall function of a merge sort. This is the merge sort. This is the merge procedure, right? So I hope you got the intuition cleared for your merge sort and how the merge procedure worked and how merge sort actually works, how to write code for merge sort and how to write code for merging algorithm. The main thing here is you need to understand this, that how on which basis, on which intuition you will be writing or you will be creating this merge sort algorithm. So if you know how this merge sort algorithm actually comes into picture, you can write merge sort algorithm. The code of the merge sort is very easy. And in the same way, if you can create a recursive tree for each of the subsequent recursive calls, as I write in the merge sort algorithm, you get the same tree here as I already discussed in the previous part of the video. Now there is one task for you. You can comment it down in this video, that what are the disadvantages of merge sort. There might be some disadvantages. Although it is taking n log n time, there are some disadvantages which will be addressed later, maybe in quick sort, or there are some other kind of sorting algorithm. But we generally don't frequently use merge sort because it has some disadvantages. So that's it for our merge sort algorithm. If you find this video useful, just hit the like button, and also if you're new to this channel, please subscribe to my channel for this kind of regular content. So bas that's it to today's video. Milte agle video pe, till then take care and goodbye.